Hello, and a very warm welcome to this event that features two great talks on the overall topic of empowering student learning and assessment in the age of generative AI. For those who don't know me, my name is Hassan Khosravi, and I'm an associate professor in the Institute for Teaching and Learning Innovation at the University of Queensland. I'm delighted to be chairing this event today, in which we'll be hearing from Professor Ryan Baker and Dr. YJ Kim, two internationally renowned scholars who are reshaping the landscape of education with innovative approaches. Before we begin, I would like to acknowledge the traditional custodians of the land I'm presenting from today and pay my respect to their elders past, present, and emerging. We recognize their valuable contribution to Australian and global society. Think about various forms of digital companions that have become an integral part of our daily lives. From smart home technologies that manage us living spaces to on-demand streaming services and augmented reality experiences that entertain us, AI-assisted navigation in our cars, virtual meetings that connect us with colleagues worldwide, and wearable health monitors that keep track of our well-being. Clearly, we're at a point where the journeys of humanity and technology are now deeply intertwined. Yet none of these digital companions are a new concept. Arguably, they've been around for at least the past decade with us. So what is all the new excitement and what has recently changed? In recent years, we've witnessed the emergence of generative AI, which simply put, has the ability to generate new content in various forms, images, text, and music, given an input. And unlike the examples I just mentioned before, they were designed for a specific task. The ones that we've seen, generative AI is the closest we've come to artificial general intelligence, which is designed to mimic high-level human cognition across a larger range of tasks. Imagine an AI that not only produces artwork that stretch our imagination, but it can also write code that analyzes data like a seasoned scientist, invent new drugs faster than any research lab, and even hold empathetic conversations to support those facing tough times. And this is just the beginning. Looking ahead, many speculate that every business, from local small shops to multinational corporations, as well as cities, public venues such as museums and parks, could all be represented by relatable, personalized, interactive personas. These digital companions would be increasingly knowledgeable, factually accurate, kind, supportive, emotionally intelligent, and multilingual, and they'll never take leave and be capable of performing actions on behalf of their owners, transforming the way we interact with the world around us. With that very quick backdrop, how can we better prepare learners for their future? In what ways can generative AI support and enhance the learning process? And how should we adapt our approaches to student assessment in light of these advancements? I'm extremely honored and delighted to have Professor Ryan Baker and Dr. Y.J. Kim with us today. So for the session, essentially, we'll start with a talk by Ryan, and then we'll move on to a talk by YJ, and then we'll probe questions and respond to questions for about 10 to 12 minutes at the end of the session. There is the possibility to post your questions and upload questions that have come by others. So please, we do encourage you to send those throughout the session, and we'll go through them at the end of the sessions. I've been following Ryan's work for at least a decade, and I've known him for the past 5 years. And his outstanding research is not just a huge inspiration to me, but an entire field of people that work in AI in education and educational data mining. Ryan Baker is professor at the University of Pennsylvania and director of the Penn Center for Learning Analytics. Baker has developed models that can automatically detect student engagement in over a dozen online learning environments, and led the development of an observational protocol and app for field observation of student engagement that has been used by over 150 researchers in 7 countries. Predictive analytics models he helped develop have been used to benefit over 2 million students. Over 100,000 people have taken MOOCs he ran, and he's coordinating longitudinal studies that span over a decade. Ryan was the founding president of the International Educational Data Mining Society, is associate editor of the Journal of Educational Data Mining, was the first technical director of the Pitt Science of Learning Center Data Shop, and is the director of Penn Online Master in Learning Analytics. Amazingly, Ryan has co-authored published papers with over 500 colleagues, not sure how that's been possible, that has been cited over 30,000 times. Great pleasure to have you with us today.
Thank you, Hassan. Thank you for your kind words. It's an honor to be here. I just wish I could have been there in person. Really regrettable that that didn't quite come out due to illness. But honored to be here, honored to talk with all of you and to hear your thoughts on some of this work. Um, so I'll be talking today about using large language models to support learners in learning. This is work in conjunction with my colleagues Maciek Pankiewicz, Rachel Liu, Mamta Shah, Tanvi Gupta, Zongtian Huang, Aaron Shi, and Nidhi Nasser. So large language models have exploded into the world, and sometimes it seems like they can do just about anything. Um, and this creates what people think might be a potential for transformation. There's been a long history of natural language processing in education, but it's historically been time-consuming to build, and it's scaled slowly. And this has led to big impacts in a few areas. For example, automated essay scoring for a small set of very scalable topics, but very limited impacts in other areas. And there's been a lot of enthusiasm about what GPT and other large language models could do for education. Sometimes it seems like everybody and their siblings have got some, learning system built on large language models up on the web, some set of prompts that will just do anything you want. But a lot of those examples are of questionable quality. And that leads to the question, where can GPT and its kind of competitors really be useful? We have several projects involving GPT in our research group. And I'm going to focus on a couple of them today, the GPTA project and the Run Code App project. And in particular, I'll be talking about GPT's abilities around feedback. GPT, as Hassan mentioned, is really great at generating text, and it's really great at responding to text. And one of our questions is, can this ability provide feedback for students that's more detailed, more tailored to individual needs, faster than what we can produce? I'll talk about that in particular with our GPTA system, and more constructive and beneficial. And in specific, can we leverage this ability in a way that deepens learning rather than just improving performance, doesn't teach students to avoid hard work, is explainable and trustworthy, really important. A lot of people are concerned about the trustworthiness of these algorithms, and ultimately help students learn how to work effectively with large language models to achieve their tasks as they go in their learning process. So I'll first discuss GPTA, which is a virtual teaching assistant that provides fast, high-quality responses on discussion forums. So GPTA is now used at 2 universities for 6 courses in 8 sections of those courses. And it does a lot of things. It answers student questions like this one here. Its uses have so far been designed in partnership with instructors. We have thus far been kind of very much customizing and adapting for each specific case. And as a result, the examples and the results I give will be drawn from several of these courses. So the first thing it does, the first big thing, and this is such a great function because students have questions about all kinds of things, and some of them are really hard to answer because they involve getting into the nitty-gritty. Some of them are very detailed on the assignments, and sometimes your teaching assistant might not remember everything about the assignment or the course materials. And so our current version for this, very iterated, is that we use embeddings to add course info to GPT. We add the course syllabus, we add the weekly slides, we have descriptions of the assignments, transcripts of videos for each week of class, video scripts for our video discussion assignments. I won't be talking about this today, but if you've ever kind of said, gosh, Zoom breakout rooms are kind of lousy, we've developed this tool where students have their conversations rather than a Zoom breakout room in a different environment where there's a virtual Ryan, a video of me, that participates, and other instructors too, that participates in the discussion, suggests to students what to talk about, and kind of scaffolds their conversation. And so we get the scripts for those videos, and we also get the course readings. We also, in the past, had the previous semester's instructor responses to questions as part of what GPTA could look up, but we found out that that was less helpful, less useful for GPT-4 than for GPT 3.5. So we quit doing that. Here's the current prompt. You're GPTA, you're a virtual assistant for this course at this university. Your goal is to assist students when the instructor is not available. And, look in the course materials. If it can't be found there, ask the student to contact Ryan or the teaching assistants. And if they ask based on a technical, coding, or concept-related question, answer based on the knowledge you have, just in general. And with this, the GPTA can answer conceptual questions about the assignments. Here's an example where the student's asking, whether this code and this approach is the right basic approach for the assignment. And you'll note here that the student even misspelled the word decision tree and is still able to interpret it appropriately. It can help students think through their work on the assignment, in this case, thinking about the relationship between variables in the data set that they've been given. The question and answer response posts are approved and sometimes not approved by the professor and or human TAs. And the reason why we still have that approval is because sometimes it goes off the rails. For example, in our very first semester of this, it tried to pick an argument with one of our teaching assistants over when her office hours would be offered. She said, "Hi, I'm Tanvi. I'm going to offer my office hours on Friday afternoons." And GPTA said, well, that's great, but if you really talk to the students to find out if they'd actually like that. Another big thing that GPTA does is offer structured feedback on project drafts and prospectuses. And this enables us to give feedback in seconds rather than weeks. And this is actually kind of transformative because imagine to yourselves, I have a class of over 60 students and the students write 5-page essays. Now, what are the odds we're going to give any kind of good feedback at any kind of high speed? And that basically means that students are going to turn in their assignments previously, and then maybe a week, maybe 2 weeks later, they're going to get detailed feedback, which they're probably going to ignore because they've already moved on. Instead of that, to get them to grapple with the feedback they get, what we do is have GPTA give them instant feedback, and then they have to revise the assignment based on what GPTA advised them to do. And in this specific case, we use embeddings to add the assignment and past instructor or TA assignment feedback. So we did find it still useful to give our feedback in those cases. And this is, I think, pedagogically, philosophically similar to UQ's feedback copilot, although we hadn't seen it when we started this work. So I was excited to learn about that. So our current prompt, we tell GPTA to give feedback, areas for improvement for each aspect of the rubric, and to avoid vague suggestions, but instead give specific actionable suggestions. And bring new insights and perspectives rather than echoing the content already presented by the student. People say prompt engineering is not as useful as it used to be, but this is one of those clear cases where it still is. If you just let GPT-4 go by itself, it will repeat what the student said a whole lot. It likes to do that for questions too. Another big thing was that we found that no matter what students put in, it always recommended that they consider learning styles. And it was really interesting because getting it to not do that was really hard. We told it, don't talk about learning styles, and it still did it. We said, don't talk about debunked theories, out-of-date theories like learning styles, and it still did it. So then we alighted on telling it that learning styles is a controversial topic. And the base prompt of GPT-4 wants it not to be controversial. And so when we told it not to be controversial, it stopped being controversial. We also told it don't give a score or letter grade, just give feedback. So there's a lot of things we kind of had to tinker to get it to be what we consider just right. And here's an example. So up here in approach, it's saying, consider specifying preliminary design principles or theories of learning and instruction that will inform your application's development. So kind of really connecting back into the assignment's goals of either design principles or theories of learning and instruction. And here, where the student talked about existing systems limitations, they didn't really get into detail about why that mattered. And so GPTA caught on to that and said, it'd be helpful to include some critical analysis of how that's directly impacted learning outcomes. Professor Mamta Shah's course, Video Games in Virtual Worlds, she had it help students brainstorm and develop their ideas. So rather than giving feedback late in the project process, feedback early. And let me show a few results. So this kind of system is actually kind of surprisingly hard to really evaluate for many reasons. I'll get into it. But one of the big things that we could tell right away was that it led to faster response time on questions. So we compared to the previous semester of the same course. This was my Core Methods in Educational Data Mining course. It's a data science course in the context of education. And in the previous semester with no GPTA, the median response was over 7 hours. And in the current semester, it was 2.2 hours. That's a pretty big difference. Now, interestingly, the percent of posts at nighttime was not significantly different. And I attribute that to the fact that we had TAs in both semesters who were night owls. But on the weekend, with human plus GPTA, it responded 29% of the time on weekends compared to 8%. And I think that's because when I would wake up in the morning at 4 a.m. ready to just launch in and get going on my paper writing. You did ask Hassan how I write so many papers with so many people. It's called 4 a.m. But I was able to really quickly open the app on my phone and say, oh, approve this post. Don't approve this post. I'll get to it later. Really transformative in the ability to get students faster feedback. So how did it compare to humans? Our students thought it was significantly worse than humans at giving useful ideas and suggestions. That's a little disappointing. That was from the semester when it was commenting on questions as opposed to commenting on assignments. So we're going to replicate that. I say we're going to replicate that. We literally just collected data on that this week, and we will be analyzing in the next couple months on whether it's better now with these feedback assignments. It also was worse at supporting learning strategies and worse at supporting motivation. And that's not shocking, because if you get a discussion post from your instructor that says, keep up the hard work, I can tell you're going to get this, it means something very different than a large language model saying it. On the other hand, they thought it was not different than humans in terms of things like responding accurately, being polite, long enough responses, and giving feedback without giving away the answer. Another thing we discovered with the immediate project feedback was an early challenge, where in the first semester and assignment where we piloted the immediate project feedback, a problematic pattern emerged. Some students, because they knew GPTA was going to give them feedback, didn't read the assignment carefully and didn't follow all the assignment requirements. And this was much more than usual. Now, GPT had been told to give them feedback on their ideas. We didn't ask it to check for compliance with assignment requirements. So GPT didn't catch this problem. The students got a bad grade, the students complained, and the instructor, in that case me, gave them a chance to resubmit. So we decided that this wasn't a problem with GPT itself, because we want to help students learn about ideas, not teach them to not read the assignment. It's actually a failure mode if students do a slapdash job on their first draft. GPT says, oh, you forgot this section, you forgot this other thing. We don't want that. We don't want to teach students not to read the assignment carefully. So we kept, in this case, GPTA the exact same, but we redesigned the implementation. And the next semester, the assignment said in boldface, the GPTA won't catch non-compliance with assignment requirements, and it's there to give feedback only on your ideas. Also, the instructor in that next semester repeated the message several times in class. The problem went away. The rapid feedback, does it actually help students? Well, it leads to positive impact on grades. We graded both a previous semester and the GPTA semester by a paid grader not involved in the study in either semester, and found that significantly more assignments received an A or A plus grade from that independent coder. Now, is that the same as learning? Not necessarily. It's performance. They're getting better performance. We haven't shown that they've internalized the messages. And that leads to some of the things we're going to do next. Among other things, we're going to look at semester. We now have, as of the end of this summer, we now have about 45 students who've taken 2 courses with GPTA, and we're going to look to see whether they make the same mistakes in the second semester they took it compared to the first semester they took it. And that'll help us see if they're actually learning it. We're also going to qualitatively analyze GPTA's feedback compared to the instructor feedback. We're thinking about doing an instructor time diary study when we can find 2 instructors where students are roughly arbitrarily assigned to sections. We thought we had it this semester, but one of the instructors became ill, so we had to cancel that. We'll be looking at student-to-student discussion facilitation and support for developing better self-regulated learning and help-seeking strategies. All right, let me say a few words about a second project, Run Code App. So Run Code App is a system where students complete introductory computer science, CS1 microtasks. And the system compiles and runs unit tests and gives feedback generated by a large language model. Now, we really got lucky on this one because my colleague Maciek Pankiewicz was planning to run a different study in the Run Code App platform he developed. And then GPT 3.5, ChatGPT came out. We said, oh my gosh, we could do something great here. So we conceived the study of putting LLM support into Run Code App immediately when GPT 3.5 came out. We implemented it in a few weeks. We ran it right away when the semester started, and then we submitted for publication at the end of the semester. So we then did our first randomized controlled study. And again, we really were able to do this because we had another study already about to run that we just subbed out. We then did some iteration and improvement. and then ran a second randomized controlled study. So here's our prompt. And basically what it does is it produces not just the kind of compiler feedback on a compiler error, for example, but says this is what it means. This is where it occurred. This is what you should do to fix it. And this is why you need to do it. So our first randomized controlled study was 2 conditions, GPT 3.5 feedback and existing compiler feedback, a little over 200 students taking introductory computer science at a large university in Poland. We found that it got higher correctness during learning. Now, one decision we made that I'm amazed we made such a good decision, because the first time you run a study, you never make such good decisions, right? But somehow we thought, you know what? Halfway through the first, we're only going to do this the first half of the semester, and halfway through the first half of the semester, we're going to turn it off completely. And so that way we'd be able to see whether students actually learned something, whether they actually were getting better even when the feedback wasn't available. And so lo and behold, at first the students did worse after the GPT feedback was turned off. But after 6 exercises, with GPT feedback turned off, and these exercises take like 20 or 30 minutes, the experimental group was slightly more correct, but even more importantly, they were much faster, saving 93 minutes across the remainder of the activity, despite initially slower performance. So this to us really told us students are learning something, even when we turn off the GPT feedback. After they have a little bit of time to burn that in and to get used to not having that support, they're actually doing better. We also found no differences in students' affect, emotion, and context between conditions based on real-time self-reports. We turned around, we iterated, we upgraded to GPT-4, we improved our prompts, ran another study. In this one, looking in detail, we found that the experimental group did better than the control group, even after turning off the GPT feedback for 5 of the 6 most common error types. And the one exception was when students try to assign a value of data type X to a variable of data type Y. And this is a relatively complex conceptual error that involves really understanding data typing and why you do it. But for simpler errors, they were all doing better. We also found that students experienced more focused, that's also sometimes called engaged concentration, or engaged, or concentrating, or flow. And students self-reported having more of that, and less confrustion. Confrustion is the emotion that kind of unifies confusion and frustration. People sometimes have trouble telling apart confusion and frustration, and there are also atypical forms of confusion and frustration that are more different from canonical confusion and frustration than those two are to each other. So we put those together. For more on confrustion, you can see a couple of our papers on this. And I think I'm going to kind of wrap up here. I've taken almost all of the 20 minutes. So I'll just kind of briefly say that we studied how we actually used GPT-4 to identify specific changes in the code by programming novices in response to the feedback. So we actually looked at how are students responding to this feedback. We used GPT-4 to help us doing some of our hybrid human AI qualitative coding, which is another big theme for us these days. Basically, can large language models help human beings do qualitative research faster and also better? And we found, brief summary, that students who weren't successful tended to just throw out what they had or add totally new code, whereas successful students were more likely to read the message, understand what it was telling them, and focus in and fix that specific thing. So we have a lot more to do. We need to kind of do more to guide students to work on the right part of the problem, because those unsuccessful students are just deleting the whole thing or adding in the wrong place. We need to look more at what works when for who. And, specifically, can we fade our scaffolding in a more in a better way than just, kind of halfway everybody gets it cut? Like, can we do better at figuring out when a student's ready for it to be scaffolded? And ultimately, can we also distill models of student knowledge and use large language models to make those models explainable for students and instructors? So bottom line, there's, these approaches benefited learners and benefit instructors. There's a lot of fine-grained attention to detail needed, a lot of iterative learning engineering, but there's a lot of potential for this to make a big difference in education. Ultimately, GPT and large language models in general are a very powerful tool. We have a lot of fun work to do as a field to figure out where it can be most useful. And the answer to that question will change as the technology changes. But there's a lot of potential to produce a next generation of adaptive learning systems, which are just better and easier to build than the previous generation. And that makes it very exciting. So thank you all for your attention. All of our latest papers are available on the web, and we have a LinkedIn and Twitter feed where we post all the latest results. Thank you very much, and I'll hand over to the next presenter.
Amazing. Thank you so much for that presentation. We do have about 120 people listening in live to our sessions. A great testament to the great work the two of you doing and your inspiration in terms of how you're impacting the work of others in the field. I have a lot of questions, but let's hold off to those questions. And please do post questions if you've got any on the Q&A, and we'll come back to questions on both of the talks at the end of the session. But with that, I'm delighted, YJ, to have you with us today. YJ is an assistant professor in the Department of Curriculum and Instruction at the University of Wisconsin-Madison, where she leads the Playful Learning and Assessment for Impact Lab. Previously, she was the founder and director of MIT Playful Journey Lab, where she led an interdisciplinary team of game designers, developers, and researchers to create playful assessment tools for K-12 education. Her work centers on the topic of innovative assessment and reimagine what and how we measure learning across formal and informal contexts. YJ's work in playful assessment merges a principal assessment design framework with justice-oriented design practices in playful learning environments. Central to her work is close collaboration with practitioners as she empowers teachers to utilize playful and authentic assessment tools that aligns with their values and address the challenges specific to their context. A very timely topic as we're all trying to rethink what assessment is once we have these large language models that essentially can do whatever we throw at them. Really delighted to have you with us today. Over to you. Thank you.
Thank you so much for introduction, Hassan. I'm very excited to be here again. Thank you. I couldn't be there in person. I'm so sorry I couldn't be there in person. I think flying all the way to here can be a little bit hard for, I guess, our bodies. So yeah, I'm gonna start sharing my screen. You guys can see my screen, okay?
I can, yes.
All right, great. Okay. So Hassan kind of started this session with some of the kind of grounding questions, and I think a lot of my work answers some aspect of that, especially related to what is really learning, and then how we should think about assessment differently when the concept of learning is also changing. So I kind of stayed in the more assessment, design, and development space where we are thinking about how we go about collecting evidence for learning when learning is going beyond discrete knowledge and things like that. So this is my group, fabulous doctoral students who work with me. So I'm gonna kind of do some kind of grounding work in talking about what I mean by assessment here a little bit. So how I see assessment is assessment as an evidential reasoning. And this is aligned with a lot of social cultural perspectives in educational assessment, where we are thinking that assessment is really a process of reasoning from evidence, although what we think as assessment is a lot of quantitative work, right? So this is a quote from about Ms. Levy. He talks about how assessment is a tool designed to observe students' behavior and produce data that can be used to draw reasonable inferences about what students know. So essentially, the tool kind of gets the idea that it's intentional design, it's a human effort. We make decisions to create that kind of context. And the goal is really producing data. But also, I want to emphasize this role of reasonable inferences. So when you look at the assessment as essentially evidential reasoning process, what you're implicitly saying is that you will anticipate that you're going to have more evidence, or the conclusion you're making can be debunked or updated when the new evidence come in, right? So I think that kind of perception about assessment differentiate kind of existing kind of view about assessment as very conclusive and deterministic. So how that actually looks like in practice. So this book on the corner is called Knowing What Students Know. So that was essentially the response by the assessment scientists and psychometricians in the early 2000s when the whole field of science of learning was emerging. When we have more evidence about understanding how people learn, then how assessment should be different. So essentially what they talk about there is this assessment triangle, which is very much based on this view that assessment is evidential reasoning. So the work of assessment is essentially connecting 3 dots. So the first one is really about cognition, a theory or a set of beliefs about how students represent knowledge and their competency. So in a way, how we think about often is learning objectives. Also, scientific understanding of how people learn, right? So a lot of literature from the science of learning. And then we think about observation. So observation really means that a set of specification for assessment task that elicit illuminating responses from students. A simple way to think about it is multiple choice test item, right? But again, like if when you go beyond that, then thinking about specification that you're thinking about. The last piece is interpretation. So it's methods taken to express how observations provide evidence about the knowledge and skills being assessed. So this is the psychometricians work often using something like IRT. A lot of learning analytics folks are here, like creating these assessment models, using algorithms and things like that. Traditionally, interpretation in assessment has been viewed as a very quantitative work. And in my work, I challenge a lot of that. And I think we're going to talk a little bit at the later how the emerging technology with AI can address some of the limitations we have so far with a very quantitative way of making sense with data. The whole point of this iterative process that you're going through with assessment triangle is essentially to decrease construct irrelevant variance, meaning anything that is not related to the construct of interest, you are trying to eliminate by going through this iterative process with ultimate goal of validity. So this is a very foundational kind of concepts around assessment. But more so than ever, what assessment scientists myself and a lot of critical measurement folks are realizing that a lot of our assessment design practices are deeply grounded in very deficit view. And this professor here, her name is Jennifer Randall. She's a professor at University of Michigan, for example. She kind of came up with this critical justice-oriented validity framework, kind of questioning what is concept relevant? Who decide what is concept relevant? Isn't the concept relevant is really on the eye of the beholder, right? So like really questioning the work of a human and the assessment designer's assumptions you were making, and really expanding in terms of what constructs you were measuring, also how we're thinking about evidence. So this kind of background, I think, is going to give you kind of sense of how I think about assessment design work. But in my work, before I start expanding really assessment using playful lens, I did a lot of work with game-based assessment. And what I realized from that work is that we're really taking a very narrow view on play. So what I mean by that is, so in education, I think it's safe to say that we value play and playfulness, right? When you go to kindergarten, everybody's playing. So the notion that is very dominant in education when it comes to play is this notion of play as progress. So it's a very much kind of Vygotsky way of thinking about play. So play is seen as a crucial activity that contributes to the learning and development of individuals, particularly children, right? It's very positive, productive, and it really helps people to learn. However, so something like this. So this is principles of playful learning, and this is principles that are established by LEGO Foundation. So some of the aspects like meaningful, iterative, joyful, these are kind of things you would think about when you think of play in education. However, play has a very diverse facets. And in my work, I've been using various facets of play just beyond play as a progress. As anthropologists and play theorist Brian Sutton Smith once said, play is never innocent. What I mean by that is you can look at play as power. When you look at play as power, that is play, it becomes a tool to assert dominance and power and control. So when you apply that lens, then you can start questioning whose knowledge are we centering in assessment and who has the power in assessment context. Another way to think about is this perspective of play as imaginary. So this view focuses on creative, imaginative, and innovative aspects of play, where folks are bringing their kind of identity and creative sides to the assessment process. The last perspective is my favorite. dark side of play, play as frivolous, meaning that play as an activity can lack serious purposes or value and can be unproductive and sometimes silly and goofy, right? So kind of counter narrative to play as progress in a way, and how that view can think us differently about assessment. So how that kind of theoretical frameworks kind of come together. So this is a paper that I published a few months ago, trying to bring all this critical assessment, social cultural perspective assessment, and science of learning, and critical play theories together to provide a design framework for folks to think about, can assessment look different? Right. So I have a link there. So if you're interested in the paper, you can go to that bit.ly link and to look at that. So I'm sure this is a lot, like YJ, there are so many errors. So I kind of want to, I hope that you read and kind of understand where all these pieces come from. But I wanted to kind of pay attention to the outcomes. So this is called a conjecture map. So conjecture map is a tool that is often used in design-based research to design a learning environment or tools and assessment tools and whatnot based on theory. So I'm just going to talk about some of the outcomes. So outcome space shows that how when this playful assessment principles are applied, how the assessment can look like, right? And I'm going to kind of pose it here so you can take a look at how those assessments can look like. And here you see things like student agency and collaboration, right? Developing pluralistic views on learning and success in learning. So there's only one, it's not like there's only one right answer and one right way of answering, but different ways of answering and different learning outcomes and constructive focusing, for example. So you might be wondering, okay, YJ, that's all great. How this kind of framework can be translated in actual classroom environment, how that look like? Great question. So I'm going to share two examples from my own work. These are both work that were in middle school in the United States, middle school context. One was in the context of maker spaces, and the other is in the context of AI literacy curriculum. So how you can think about more concretely when you're trying to apply this playful assessment principles is that what is kind of the spectrum of play? So this is work from Bernard Gilmore and Katie Sell and Eric Zimmerman also talk about their work as it's a kind of spectrum. So play can be viewed as a spectrum. The most structured form of play is actually game. So game often has arbitrary rules, right, and constraints. And then you can think about playful activities that are, things like wordplay, role play, playground activities, those kind of things. And the last kind of most loose kind of spectrum is being playful, like being goofy and like injecting some of the playful spirit and flavors into the thing you're doing. So in playful assessment implementation that I have done, I kind of vary across this kind of spectrum. So the examples I'm going to share with you here is kind of the idea of being playful in assessment tools. So what you're looking at in this picture, I don't know if you can see this picture papers on the table. So these are paper-based tools. And the idea is we got the idea from Bingo. So basically students are, when they are demonstrating and when they recognize their peers are demonstrating certain skills, they can mark on the paper tool. So how we thought about is, okay, what are some of the important constructs that we know that students are demonstrating in Makerspace, right? So I know a lot of teachers are using Makerspace because of that engineering STEM skills. But when you talk to teachers, they will say, well, that is important, but more important things that are really hard to measure are things like agency, design process, social scaffolding, which is another way to say collaboration, productive risk taking, right? So we work with teachers to come up with what this construct are, and then we talked about with them how that actually looks like in classroom. So this I statements on that you're looking on the right is the statements that we come up with teachers to communicate to learners when you're, for example, productively risk taking. This is how it's going to look like, because often students don't know what that means, right? They even don't know what the learning outcomes mean, not to mention this kind of 21st century skills. So we've come up with this kind of poster and definitions and this I statements to communicate learners what we're talking about. And oops. And I'm going to talk about some of these playful assessment tools. So it's called a Sparkle Sleuth. And literally, it's a piece of paper that you're looking at on the right side. And students get to collect these clips of paper when they can self-document, like when they have this moment of aha or oh no, or other sparkly moments. And so teachers can walk around and they can, when they notice something, they can quietly write down something and they kind of pass it to the students, and they can do that to students can do that to each other. So they can kind of embed this throughout basically activities to be able to kind of capture those moments. So this is how it looks like. The picture on the left, this is students kind of wrote that to each other. And one of our teachers decided that I'm actually going to use this memorandum paper on the right and then write down and then give that to the students. Very qualitative evidence in a way. And another tool is called this Make a Moment punch card. So I'm a big coffee drinker. I heard Australians love coffee as well. So, the idea kind of came from, you go to your coffee shop, 10th time you get the free coffee, like how delightful that is, right? So students have similar kind of idea here, where every single time when they feel like they took a risk, they get a stamp here or gonna make a hole on their punchy card. And on the back of the card, they can write down what that thing was. So at the end of the session, or they can look at it with their peers, with the teachers, and talk about how they took risk and how that kind of pay off or not paid off. Another example that I want to share is more playful activity. So it looks like an activity that all students are playing, but at the same time, that it can generate evidence for their understanding. And this is in the context of AI literacy curriculum for middle school classroom. So I don't know, I'm sure many of you guys are familiar with this machine learning pipelining and the idea of like the multiple sources of bias. So as Hassan mentioned earlier, AI is everywhere. And there are a lot of efforts in K-12 education to teach AI to young people, K-12 space, right? But the really critical aspect that we can miss is this ethical idea about AI and how there are multiple biases that are baked into the AI process and how it can be harmful to certain people. So how we thought about in our AI curriculum is that instead of focusing on coding and developing tools, this is the kind of standard approach to teach AI, but thinking about, are there fundamental ideas of AI literacy that we think that is so important, even if you're not a coder, even if you don't know how to code a single line of program, can you still understand what are some of the fundamental ideas of AI? So this is the idea that we kind of focused on. And we come up with this playful activity. So what students need to do is students need to kind of pose. So we divide students into two groups. One student is input data or training data. The other student is testing data, basically. And the training data students basically do some kind of embodied pose. So the category here is winter sports versus household chores, or summer sports versus household chores. And then there's the students who play the role of AI agent. And there's a students who play the role of labeler, so supervised learning. So all students participate, and this was a computer science or ICT course in middle school, but they essentially didn't use any computer. So I'm going to show you how this works. So as you can see, the students line up, there's the data, the label, and there's the AI agent. And then you can see students are posing. Some of them grabbed the prompts from the classroom. So I can imagine, for example, the students holding broom. This is winter sports. And can you imagine which sports is this? It's it's curling, right? Curling. Yeah, it's a curling. And the student with the gray hoodie on the left, it's the ski jump, right? But you can imagine how easily that can be confusing. So yeah, by participating in activities, students get to understand, again, fundamental processes of AI. The reason we're very much in the process of analyzing data I can tell you like why this is impactful in two ways. So first is everybody gets to participate, and like especially I also heard that STEM inequity is also concerned in Australia, and the same in United States, especially for girls. So in this picture, this girl is on the left, right? The teacher is telling how they rarely say anything throughout the whole class, right? But they were participating, they are actually excited, and they were demonstrating. So that's what I would like kind of importance of making this kind of things more playful. And the other way is because how students participate in this is different. And then when I don't have the slide for that, when you ask them how they demonstrate different ideas, they can actually articulate in a more inclusive way, right? And the last piece that I want to emphasize is that students, excuse me, oh, I lost my phone. I'll get back to that later. So last piece I want to talk about is the very important role of teachers, right? And again, like as we're thinking about like what are different kind of learning that we need to emphasize in classrooms, and when we are reimagining what assessment is, teachers' role becomes more essential. So in my own work, I've been developing a lot of playful tools and also playful learning experiences for teachers, for them to be quickly kind of unlearn some of the things they know about assessment and relearn what assessment can be. So this is an example called assessment party. I don't have it in my physical copy, but it's essentially a standalone. It's a game, card game, like board game kind of thing. It's in a nice box, and teachers can take it to their professional development context, and they can play with their colleagues. So I'm going to show you how it looks like in their PD session. So again, there's a teachers learning about assessment. Usually there's not that much laughter, but I don't know if you can see this. Oh, there you go. I don't know if you can hear. So I'm gonna pause and explain what's happening. So this assessment party was based on the idea of assessment triangle. We talked about that briefly, right? So there's observation, interpretation, and then construct, right? So this teacher is acting as the observation, the performance corner, and this teacher who's taking notes is documenting evidence, right? But this teacher who's covering their eyes is the one who's going to look at only the note, not the performance, and make sense with what this performance was about. So doing the interpretation. So essentially, the assessment party is trying to get at is by having teachers role play certain elements of assessment process, they can start kind of, they understand this process, but they can also start question a lot of assumptions you were making about assessment. So it looks really goofy and silly. What teachers can learn from this? We are also in the very much process of analyzing data. I'm just going to share some of the sticky notes from the PD session. I want you to pay attention to the sticky note on the left. Again, like this was like an hour experience, and teachers start asking students to bring their own unique experience and their perspectives to the classroom. And assessment should allow space for that, right? So they're really trying to get this culture relevant, right? More individualized aspect of assessment that they were not thinking about before. So lastly, since this is about AI, I feel like I have to make kind of a connection here. You might be thinking, YJ, these are great, but these are all qualitative. Like, are you saying that anything can go? Like, how can we scale, right? All the kind of standard questions you were asking when you were talking about assessment. So as I mentioned earlier, although assessment traditionally has been very quantitative in terms of this interpretation methods, if you think about the reasoning process of assessment, that is very often qualitative, right? So in my work, I've been converging this qualitative data and qualitative evidence and emphasizing qualitative reasoning to come up with a more convergent assessment model using Gen AI's capability in terms of automatic coding. So I've been doing a lot of automatic coding using GPT and coming up with a human code book using that as a tool to basically rapidly process some of this qualitative evidence to come up with assessment models and to visualize some of this assessment or qualitative insights. For example, I use some of the visualization methods from quantitative ethnography. I don't think I have a slide here. I can talk about that a little bit to kind of combine that with some of more traditional quantitative evidence to have a more comprehensive look at students' learning. And I don't want to sound like AI will solve every problem person, but I think especially in terms of rapidly processing qualitative data and kind of fine tune to be able to kind of center some of the localized insights in the process, I think has a great promise in terms of advancing how we're doing assessment for sure. So to wrap up, playful assessment is grounded in social cultural asset-based perspective, and it can guide us in terms of design assessment materials and processes. And really the ultimate goal is enabling students and educators to have different kind of relationship with assessment. And I just want to emphasize that place assessment also challenges us to rethink what good assessment is beyond easily quantitative metrics. What I mean by that is often in assessment, when we talk about psychometric qualities, we look at reliability and validity based on really quantitative metrics. And I think that we can do better if we're thinking about good assessment. So some of the challenges, I'm sure all of you are thinking about this, assessment for learning versus of learning and like the needs for standardization, how can you make a balance. And also being really intentional about for and with whom. And again, like assessment has been in a very deficit framework and has been harmful to some of the groups. So how we can undo that, I think is really important. Again, it's not about tricking learners with a shallow fun, but it's really making it as assessment is really deeply integrated with the learning processes. So that's all I have for now. And thank you so much for your attention again. I'm so sorry I couldn't be there in person. And if you have any questions, you can shoot me an email. Thank you.
Amazing. Thank you so much. Playful assessment, such a good idea. Like, why don't we all just make it playful? I'll while you're getting your questions in for the second part of the talk for the playful assessment, I might start with some of the questions, Ryan, for you, and I'll try to reword some of these to see if we can combine some of them to come together. You mentioned that essentially in the second semester, students are getting the responses faster, but not immediate. I'm assuming you could give it to them immediately if you just provide the feedback in real time, but everything seems to be instructor approved before it goes live to students. Is that the case or why?
So not the feedback. The feedback is essentially automatic. It takes like a couple seconds. The the responses we still put through an instructor filter just to make sure that it's on message, and usually it is. But there's a few cases where it's not, and there's kind of an expectation. This is one of the reasons we have a discussion forum as our metaphor rather than a chatbot, because a chatbot you expect to respond immediately. A discussion forum you don't expect to respond an immediate response, and so it's okay for there to be a few hours where the instructor or a human TA checks it and makes sure it's on message. For the automated feedback on assignments, we don't expect that to be perfect, and we kind of message it's not going to be perfect, but it's better than nothing, and and a lot better than nothing. And so there it makes sense to be faster.
Yeah. Have there been a lot of things that you've rejected, or what kind of things would you tend to reject if you're reviewing what they've done?
Honestly, the most common rejection case is a case where like person A posts and it responds and it's good and we accept it, and then person B posts and it like kind of it's not as good at handling like the fourth step in a conversation thread. It sometimes like goes back to the first one or repeats what they both said, and so we're more likely to reject it kind of further on. I can't remember the last time we've rejected it for being technically inaccurate. We're often, except for like the learning style stuff that it loves, typically we are rejecting it because the conversation isn't of the right form anymore when it gets too far.
Right. You noted that you ask it not to provide any grades. Is there a reason for that? I mean, to put it in terms of the question, a grade might give them an actual indicative of how well they're doing, that you take it that way.
I mean, that's a good point. There's two reasons we don't do it. One, we want them to focus on the content here, not on their grade. And two, I would feel really bad if it told the student that they were going to get an A on the assignment and we eventually gave them a B, right? Like, there's a case where kind of even one false positive in that direction is too many and causes a mess for us. So it's just better to keep it on the level of ideas. That's better for the learning experience, and it's a little safer for not encouraging somebody to call it a day.
Yeah. It was really interesting to see that you've compared results on high achieving students, whereas a lot of the work we have in the community has always been looking at risk students. How can we help with risk students? Do you think this also helps students who are at risk or low achieving, or any thoughts there?
Oh yeah. And I didn't mean to say that it's only for high achieving. I was comparing, and I think with the slide you're talking about, I was comparing, I was going a little fast there, my apologies. I get a little excited sometimes, but I was comparing high achieving students to low achieving students and what they do. And this was actually not who was high achieving to begin with. This was the outcomes they get.
Again,
So
right.
if they do certain things, they end up doing well. And if they do other things, they end up not doing well. So we do need to support those students that aren't doing as well out of it. And that's going to be the kind of emphasis of our next design. But it's actually not that we have done other work where we compare what students who started out ahead and start out behind do. And it seems to kind of benefit both groups. But what it really differentiates on is what they do in response to the feedback, whether they end up doing well or not.
Yeah. You mentioned fading away scaffolding, right? I've got examples of things that we never fade away, like typos, or when we help with spell checkers. Do you think there's a need to fade away the AI assessment, or can we just take it for granted and use it all the time?
I mean, that's a really good question, right? Like things like GitHub Copilot and I use ChatGPT for my programming practice all the time. I mean, those are things that don't fade away. I guess the question is, do we need students to understand these things, right? And I would argue that being able to understand variable typing, which is one of the things we're not fully succeeding at yet, is one of those things we need people to get. Similarly, goodness, if you can't get your semicolons right, you are going to be really a bad partner for GitHub Copilot, right? So I think that the kind of mistakes people make in a CS1 are the kind of mistakes that we need to get them to not be able to make. And some of the things that we provide so maybe it's even kind of the opposite of the spell checking case, right? Sure, it can fill in your semicolons for you, right? But I mean, like, basic mistakes that involve core comprehension of computer science concepts are things we need to get people to be able to do so that they can effectively work with these tools in the future compared to some of the more advanced stuff.
A question on copyright content for the course, because obviously you probably
Yeah.
have to upload that for it to respond well. Are there any challenges there?
So first of all, every reading in my courses are papers that can be found on the public web, pretty much. So they're probably already been crawled. But first of all, I see this as fair use for educational purposes, and there's a long-standing copyright. I don't know actually about Australian law, but in the United States, there's a long-standing exemption for fair use for educational purposes. And second of all, we're uploading it under an API terms of service that explicitly promises not to train on our uploads, and that they indemnify us if they do that. And they also promise to delete after 30 days and only review for abuse or misuse. So I feel pretty comfortable about this. There's some big debates about whether we should be allowing copyright on people's art in general, and whether we should be allowing training on art in general, and whether it's okay to violate that these developers violated copyright in general in creating the large language models. But the uses we have for the which we're doing here, I feel pretty comfortable that we're within the law.
Yeah. There might also be just a little bit of difference in terms of the Australian context, where the content of the courses are often owned by the university rather than sort of the academic freedom, which might be a little bit more flexible in the North American context of you own your own material.
And let me clarify that yes, our resources are also owned by my resources in my course are owned by the University of Pennsylvania, but they've allowed me to do this.
Okay.
There's
an
nobody here is
approval
concerned.
process there. Yeah. YJ, I want to turn to a few questions on the assessment side. And again, super exciting and really thinking about how it could be so much different to what we do today. One of the things that looking at the examples you've got me thinking about, analytics of what that playful assessment looks like and what sort of criterion you can have and how can we go back and judge it. Is there any thoughts you got, or is there any good pointers you can give us in terms of what analytics would be good for playful assessment?
Yeah, so I have kind of two responses to that. So Dragon at Monash always talks about how we don't know how to good as a field, we are not good at getting good data, right? I think so. When you're opening up assessment space, essentially what you're doing is that you're kind of dealing with a more complex, right, social cultural data, and that means that you have to think about analytics model for a lot of assumptions you're making. So in my work, looking at the playful assessment data, as I mentioned very briefly, I've been using, for example, epistemic network analysis, where we are coding the classroom data or the data that collected from this messy assessment tools that you guys saw, and be able to actually leverage teachers' codes. So teacher come up with, these are kind of evidence, or these are the concepts that I care about essentially. And then you can start visualize different kind of epistemic network, for example, across different learners. So their strengths are that being demonstrated in a different way, and it's more qualitative rather than Hassan is 90% versus Ryan is 50%. So that way teachers can start kind of paying attention to what that actual numbers actually mean in that context. So that's one way to think about. Another way to that I think that the analytics is going to play a really, really, really important role is psychometrics. So, at the end of the day, we have to understand, especially if we want to scale this, like how these things actually function, right, across different contexts, across different learners, what it means to have generalizability, validity, fairness, and those kind of things. And I think that psychometrics, traditional more psychometric ways of looking at this can be really limiting to be able to really provide rich evidence for psychometric qualities. So I think that a lot of that things are happening in the analytics field can really opens up different ways of looking at that goes beyond this just number.
Amazing. YJ, we'll pick this up in the summit in Melbourne on Thursday, where we talk a lot more about assessment there.
Yes.
But for the time being, unfortunately, we're just over time, and I do realize many colleagues might have other commitments. So maybe we'll call it to an end here. Thank you both so much again for your valuable time and contributions. And thank you everyone for joining us today and your great questions. Until next time.
Thank you all.
Thank you so much, guys.